Hey guys, this is the revision for counting and probability, so counting principles and probability. We are going to revise different aspects of probability like different tools, instruments like Venn diagrams, lattice or grid lines, probably just listing tree diagrams, and actually we're going to consider several problems that are actually might consider as really hard and probably medium levels. Alright, so grab your pens, grab your notes, and we start doing that. So make sure, by the way, you watch the crash course for probability where I actually explained how the instruments work, how to apply, in which case to apply, and which is better. So make sure you watch that. That's actually probability in 2 hours, the whole course. So if you wanted to revise, this is exactly the right time to grab your pens and notes, and let's get started. So pause the video, try to do by your own, and here is going to be my explanation. So the first problem, you need to, what are you going to do? So assume that set M is the set of prime numbers less than 6, and set N is the set of odd numbers. Both sets M and N are such that M is from Z plus, so basically M is a subset of positive integers, as well as N. What we need to do, we need to draw Venn diagrams representing sets M and N. Here, what I'm going to start from. So Venn diagram, all right. We have a universe. In this case, universe is represented by Z plus. So you can say that Z plus is going to be universe for us. So all possible numbers in this case, because each set and each subset represent numbers. So Z plus, okay, we're limited to that. So what about set M, first of all? Let's consider set M prime less than 6. I'm going to list first of all because it's much more convenient if you list two sets so that you get what numbers you need to include. Prime numbers less than set, they start from 2, so I just simply listing them 2, 3, and 5. There are 3 numbers in that subset from Z. Okay, what about N? Set of odd numbers, in this case we only include 1, 3, and 5. Alright, we've got 3 elements in each subset, and that's why it's right time to depict on a Venn diagram. Let's say this is gonna be set M, and let's assume that this is going to be set N. Alright, so here is N and here is M, and now we're going to depict those elements. 3 and 5, they're in the middle. This is intersection, 3 and 5, so you can say that if you consider M intersect with N, you'll get 2 elements, 3 and 5. Because those elements adhere to each of the sets. Okay, so next one, 1 and 2. So 1 is here, that's unique for N, and 2 is the prime, and it adheres to M set. Okay, so what about other integers? Because we have universe Z plus, so other integers positive integers that you didn't include in M and N is going to be the complement to both M and N. So that means we set up right there, and in this case I'm going to set up that. So in rectangle, I just list them starting from 6, 1, 2, 3, 4. So we need to start from 4, then 6, 7, and so on until to infinity. All right, positive integers. Okay, next part, you need to draw a lattice diagram to reflect the sample space. So in this case, we actually selected elements that we include into M and N. And here is the right time to use another instrument, what is called lattice diagram, or it's also known as the grid lines. Let's switch to the next slide. Now we need to include, so what I'm going to do, I'm going to copy MN, so we can basically say that M and N, we just copy, so prime numbers, 2, 3, 5, and the same for N. So 1, 3, and 5 over there. Okay, and now we're going to use this instrument. So that's why I'm going to switch a little bit. Oh, probably not. Okay, that's also enough. Okay, that's one axis, and this is another axis. So each x stays for corresponding subset M and N. Let it be M here and N here. What we're going to do, we're going to lay out elements. So 1, that's for N, 3, and 5, and we're going to do the same for M. 2, 3, and 5. And what we're going to do, we're going to put grid lines here. Okay, so there, horizontal grid lines, and do the same for the vertical. So that's typical presentation elements in lattice. So, and the nodes, if you depict the nodes, you'll have all possible sample space here. Okay, so basically different combinations. So we need to reflect the sample space. So in this case, we might have different combinations, right? However, lattice diagram is very suitable to find answer to the last question. So in this case, let's consider what the sample space actually. If we consider n elements 1, 3, 5 and m elements 2, 3, 5, we have some common, right? So let's have a look where we have common elements, like 3, 3, it's right there. 5 and 5, we also have, yeah, and that's it. Yeah, and that's it. But what about 5, 3 and 3, 5? That's also the case. So, and 5, 3 over there. So we have actually 6 elements. Let's count them right now. And the lattice. So 1, 2, 3, 4, 5. Yes, 5. And we actually have repeating elements with combinations 5 and 3, 3 and 5, 5 and 5. So actually those elements are repeating. So we have 5, so 5 also there. So that's why we can say that in this case, we only can check out, so on top of those 6, so those 6, and combination 3 and 5 and 5, 3. Actually, we repeat, so we can choose any one. So lattice diagram, it's also possible to show the sample space and selection for sets M and N. Okay, however, I think that lattice diagram will be much more appropriate if you want to go and answer that last question. You have M and N are elements such that M is from M, and so that means you have an element that is the element of the set M, and N is the element from set N. You need to answer the question, how many different sums in the way M plus N are possible to complete. So basically, if you take the elements from set M and N, how many possible summation you might complete and they should be different. So the keywords also different. Okay, I'm going to use the green one, so maybe bold, and let's calculate how many possible different sums. So before we do that, actually I want to calculate m and n using lattice diagram. Let's have a look there, and first fix the result for m plus n. So here elements will represent the sum m plus n. Okay, so let's get. So 1 and 2, so 1 and 2 will get 3. 1 and 3, that's 4. 1 and 5, that's 6. 3 and 2, 5 here. 3 and 3, 6. 3 and 5, it's going to be 8. Next one, 5 and 2, it's going to be 7. 5 and 3, 8 again, and 5 and 5, 10. Okay, so that's elements on lattice grid lines intersection represent the sum m plus n. And now we can easily find the answer to the last question. I just simply make them, circle them, starting from the smallest sum up to the highest. So 3 is unique sum. So 4 is also unique. 5 is also unique. What about 6? We have 2 ways to arrange 6. So that's why we can tick or circle only one, because the other it's actually the same. So what about 7? It's unique. And 8 we again circle only one time. And the last sum that will give us 10 is also unique. So we have in total, we have 7 possible ways to arrange our sum in the way m plus n. Okay, so basically this is the very fast track if you use lattice diagram. Okay, so by the way, you can answer the question, what's the probability, if you like, if you want to complete the sum, and let's say the sum you might take from all possible sums, even they are the same. So basically, in total you have 3 by 3, 9 ways to represent the sum. That's the total number, or basically the sample space, how to arrange the sum. And what about for 7 possible ways? The sum is different. So what if the sum is different? In this case, the probability of getting sum different is going to be 7 over 9 ways. Okay. But the question actually asks about just all possible combinations that we can arrange. Okay. Let's move back and try to answer the last question using the Venn diagram. In this case, I'm gonna, on top of the Venn diagram, I'm gonna use the listing. So I just simply used lists for the sum n plus m. And I want to list all possible ways that we can arrange using our elements. So if you take 2, you can add with 1. So the first sum is 2 plus 1. So 1 plus 2, that's actually the same sum, but if you have a look here, so 1 and 2 and 2 and 1, we circle one time, so we don't need to double that. So that's why we will consider only unique summation. Okay, so next one, we take 3 and add 2. Then we take 5 and add 2. Basically, I took common elements 3 and 5 and add with unique element for m. I'm going to do the same for subset n. So I'm going to use 3 plus 1 and 5 plus 1 as well. Okay, if I add 3 and 5, I'll get 3 and 5 also. Okay, that's the last one. So no, it is the previous one. Okay, let's just have some totals here. I've got 3 here, I've got 4 here, I've got 7. So 4, 6, and 8. How many? 1, 2, 3, 4, 5, 6. Okay, So however, we have doubling 4 and 4. So that's why right now we're going to take only unique. So 3. So 1, 4, 6, 7, and 8. And this is double, so we can write as basically double. So we can erase that for a while. And so what also possible if we add all 4 elements, 2, 3, 5, and 1. So 1 plus 2 plus 3 plus 5, we're gonna get 10, and that's gonna be the last combinations, the last combination here. So we've got also, so how many? 1, 2, 3, 4, 5, 6. Yeah, there are only 6. What the last combination that we're looking for? If you check for all elements, we need to have 3, 4, we need to have 5. How to get 5 is 2 plus 3, and this is actually what I messed up here. So 2 plus 3 is the last combination that we messed up. Alright, so that's the last one. 1, 2, 3, 4, 5, 6, 7. All different sums. You can check by your own, okay? So I hope you have the same, but as you can see, Venn diagram, on top of that, you need to apply listing. So it's pretty, like, it's much harder than if you use lattice, because in lattice, it's much more transparent and it takes less time for you guys, okay? That was the problem that you need to pay attention to. This is definitely higher maths. It's not foundation. And also make sure that you understand those notations that used here, so that you understand symbols and you understand the meaning of that, okay? So hope you have the same. So this is using the lattice, this is using Venn diagram, and final question answered 7 different combinations for the sum n plus n. Here's the same, different ways, and even just as extra, give you an idea how to calculate probability if you ask about that. That was Daniel Dallas. Hope you like that. We'll continue doing revision for probability and counting principles. Stay tuned up. Peace.